Welcome to EHEDG Connects Zooms in which we zoom in on EHEDG guideline document details with the contributors to these guidelines, the EHEDG working group members. And with us today is no one less than the EHEDG president, Hein Timmerman, and he is also the chairman of the EHEDG working group, CIP. Hein, thanks for joining us today.
Thank you, Rob, for this words of welcome, this introduction.
Now we are going to zoom in today on a chapter of EHEDG Guideline Document 50 on the hygienic design requirements for CIP installations. And we focus on a chapter that deals with information about the parameters within a CIP system. Why is this particular chapter so interesting in this EHEDG Guideline document?
We know that CIP is a widely used application for cleaning. We want to avoid the human error, and to avoid human error, we need automation, we need to measure, and we need sensor technology. And we see in the EHEDG world that certification of sensors is a big part of our daily business. We have a huge amount of certified instruments, of certified sensors that we can apply. And these are applied in an automatic CIP, because if we want to automate, we need to know what's going on.
Well, we've seen quite some innovation going on in the space of sensor technology. Many new EHEDG certified sensors have hit the market. This new innovation, is that incorporated into this new EHEDG guideline update?
Yes, indeed. And what we see is also a big step towards innovation in sensors. The knowledge, the universities are studying on more things to measure. We want to censor the development of a biofilm, the development of a fouling in an installation, and we want to really know with sensors what is going on in the invisible part, in the inside of an installation, which is hard to reach.
Now, your guideline, and specifically this chapter in the guideline, focuses on the positioning and the usage of sensors in such a way that they don't introduce new food safety hazards, and that they yield optimum insights to optimize the CIP processes. What kind of questions do you get from the end users, usually in your own consultancy business?
We often get the question from the designers, from the end users, what is the minimum configuration of sensors that we need? And where should I put my sensors in order to be able to run my CIP? And what do I need?
Now let's zoom in on a table 6 on page 43. What do we see here?
If we zoom in there, we see what is CIP. CIP is running the parameters which are crucial. It is the flow, it is the temperature, it is the concentration, and then with a room for all additional informations and all new sensors which are growing in the market, which are developed, which are tested and validated to give quality, high quality add-ons in this configuration.
How exactly did the working group envision the end users to apply the information contained in this table?
The end user, with whichever state he is in, he can make a selection. Okay, I need to know conductivity because this is a direct correlation with the chemistry which he uses. I need temperature because we know cold cleaning, warm cleaning. In some food soils, you need hot cleaning and you need certain time temperatures. And this is essential. You cannot run a CIP without having information on temperature.
Okay, now you have this information as an end user. What are you then going to do with it?
If you have all these informations together, you streamline them and you bring them to your management information system, you can start programming and making the right decisions. The right decisions first on the known values, on the empirical values, which we know an installation is clean, and then you can bring in the new data management and have the algorithms work out better ways to optimize your CIP, because optimizing, we know that a CIP is one of the biggest water consumption in a food factory. So we have to be sustainable in the future, and EHEDG will address sustainability in future guidelines. But the heart starts with a well-functioning, optimized of installation and knowing which sensor to place where. And this is exactly the zoom in that we wanted to provide in this holistic guideline.
So if I understand you correctly, this table provides something like a first entry point, an overview for anyone who wants to find their way through other parts of the guideline, other parts that, for example, deal with the correct implementation of instrumentation in a CIP process, like this table figure 24. So how important is a correct application of these sensors in CIP systems when you actually add them to, for example, an existing CIP system?
This is what we call, what we describe also in other guidelines, is the hygienic integration. And a CIP unit is a CIP guideline, is a typical example of an integration of pumps, of valve, of instruments to make a full installation as hygienic as possible with the least risk for contamination. Another topic that is in this guideline is we never should contaminate our post-rinse water, because this is the last thing which is in the installation before we start production. And so a lot of measures. So and this is all described in this big guideline. If we zoom out and you read the full guideline, you really understand where the risks are, how I can operate, how I can recover, lower my cost, how I can optimize for the future, and what is going on as today's innovations. So this is what brings the real value of this full guideline.
The real value of the entire EHEDG guideline series, that's what we want to illustrate by zooming in on a detail of a guideline here. Thank you very much, Hein, for doing that. And dear viewer, if you want to know more about this topic, just download the entire guideline from the EHEDG website. It's free for all EHEDG company members. And if you're not an EHEDG company member yet, well, this might be a good moment to become one then. Thank you very much for watching. See you next time.